Okay, so this is the homework help video for Honors Math 3, Unit 4, Objective 4. So I'm going to start with question number 5. So for the limit, the first thing I want to do is always direct substitution, right? I always want to try that. So when I substitute in 4, I will get 4 minus 4, which is 0. And then substitute in 4 here, so I would get 16 minus, and then 32. Plus 16, and so that gives me negative 16 plus 16, which is 0. So I get 0 over 0. So as soon as I get the indeterminate form, right, so that's indeterminate, then that means I probably can solve and find a limit. So my techniques for finding a limit is I can factor and reduce. If I have radicals, I want to rationalize either the numerator or the denominator. And if I have a complex fraction, I want to multiply by a common denominator. So for this one here, I want to factor. So in my numerator, I can factor out the negative. So that would give me w minus 4. And then in the denominator, I would get w minus 4 times itself. So then reduce this, so I'm going to reduce that, and then as soon as I do that, I want to rewrite the limit. So we don't want to get lazy here, right? We want to rewrite the limit. So then I would have the limit of my new function, so negative 1 over w minus 4 as w approaches 4. So now I want to take the limit of this function, so I've reduced it, so now I'm going to substitute in 4. So I would get negative 1 over 4 minus 4. Which is negative 1 over 0. And then that is undefined, so then therefore the limit does not exist. And then I can use that abbreviation D and E, right? So the limit does not exist, not because we had 0 over 0, but because I ended up with negative 1 divided by 0. Okay? All right, and let's take a look at number 7. So again, the first thing I want to try always is direct substitution. So I'm going to put 0 in for y, so 0 over 0 minus 1, and then 0 divided by negative 1 is 0, so then the limit would be 0. Okay. And then let's take a look at number 15. So the first thing I want to do is substitute the negative 3 in. So I'm going to do that down here. So I'll have 1 minus a negative 3 minus 2, and then negative 3 plus 3. So that's just 4, right? 1 plus 3. So the square root of 4 is 2, and 2 minus 2 is 0 over negative 3 plus 3, which is 0. So that's indeterminate, and whenever I get indeterminate, I always need to try to find a limit. So this is a radical, so I want to rationalize the numerator, So to do that, I want to multiply the top and bottom by the conjugate of the radical, right? The conjugate of this one. So that would be root 1 minus x. Instead of subtracting 2, I'm now going to add 2. And whatever I do to the top, I also have to do to the bottom. So then when I distribute, because this is a difference of 2 squares, I'm going to multiply these two things together. So that would be the square root of 1 minus x times itself, so squared. And then this will give me the positive and then the negative version, right? So that would cancel. So then now I just need to do negative 2 times 2. And then I do not want to distribute this, right? So you only want to distribute the piece that are conjugates. Leave this factored. And so the square root of something squared is just going to be itself. So that would be just 1 minus x. And then let's combine like terms. So I have 1 minus 4, which is negative 3. And I'm kind of running out of room here. So, see if I can smush it in there. Okay, so then now from here I can factor out that negative. So let me come to this side a little bit. And then that cancels here. And then as soon as I get that factor canceled, then I want to take the limit. So I'm out of room here, so I'm going to go onto a different piece of paper. And again, this is where we don't get lazy, right? You need to write that limit or you are not going to get full credit. So I am now done factoring and reducing. So I'm going to be taking the limit of my new function, so -1 over root 1 minus x plus 2, and then as x approaches, I'm going back to the original problem, so -3. So this is my new function, right? I've canceled out that 0 factor, and so now I'm going to substitute in my value for x. So this will still be -1, and then I'm substituting in -3, so 1 minus -3, so that would be 1 plus 3, and then plus 2. And then that ends up giving me -1 over the square root of 4, and then plus 2, so -1/4. Okay? All right, and then let's take a look at number 17. So I'm going to do 17 on a separate piece of paper as well, just because I know I'm going to run out of room. There's really not enough room on here. Okay, so that's 17. Give myself plenty of room now. Okay, so I want to always substitute in the 2 first. So I'm going to put in 2 here. So that would give me 2 plus 2 is 4. And then 2 minus 2. So I would get 0 over 0, which is indeterminate. And whenever I get indeterminate, I always need to look for the limit. Okay. All right, so in order to do that, I want to multiply by the common denominator. So I'm going to be multiplying by both 4 and x plus 2. So this is not here, so let me erase that a little bit. Okay. So my common denominator, so I'm multiplying by 4 and x plus 2, and then I want to distribute it to both of those, but not the bottom, right? Don't distribute the bottom. So when I multiply these two together, the x plus 2's are going to cancel, right? And I'll be left with just 1 times 4. So the x plus 2's cancel, and I'm left with 1 times 4. And then when I distribute here, the 4's are going to cancel, right? The 4's are going to cancel, and I'm left with -1. So -1, and then times x plus 2. So the 4's cancel, and I'm left with the -1 times x plus 2. And then I don't want to distribute the bottom, but I'm going to put it in the correct order though, meaning the 4 first. So I cannot reduce these, right? Because this is not a factor of 4, it's subtracting. So I'm going to distribute the -1 in. And then combine like terms. So 4 minus 2 is 2. And then I can factor out a -1, so I'm going to do that. And then cancel my x minus 2's. Okay, so as soon as I cancel that factor, then now this is when I want to take that limit. So now for my limit, so now I'm looking back at the original problem, so back here. So it's the limit of x approaching 2, right? So I have the limit of my new function, so -1 over 4 and x plus 2, and that was as x approaches 2. So now I'm going to substitute 2 in for x. So I would get -1 over 4 times 4, which is 16. And then there's my limit. Oops, you could see none of that, could you? Okay, so there it is. So replace 2 in for x, so 2 goes into here. And so then 4 times 4 gave me the 16, and then under -1. And that's it.